hit the record. So good morning, everyone, and welcome to today's webinar, which is Drain Water Heat Recovery in Action from Single Family Homes to MURBs. And it's presented by our team here at ENERQUALITY. My name is Joanne Fraraccio. I'm the Education and Events Manager here at ENERQUALITY, and I'll be your host for today's session. So before we get started, just a quick note, today's webinar is going to run about 45 minutes. Please feel free to enter your questions into the Q&A section. It's best if you use the Q&As because that way we can kind of collect them there. And when we pause for questions closer to the end, because I want to give Marc a lot of time to present what he's going to talk about. And then we'll go through those Q&As. And if we kind of run over, then we can at least spend a little bit more time in those Q&As there. Okay, so we're going to do our best to address them at the end, but we'll also leave a little extra time there. I'm very pleased to introduce our presenter, Marc Fontaine, co-founder of EcoInnovation Technologies. And in just a moment, I'll go through Marc's bio, but on the next slide, please, Marc, I'm going to talk a little bit about what we do here at ENERQUALITY. So as many of you may know who we are, ENERQUALITY, we proudly present, we are one of Canada's largest qualified net zero service organizations. We provide program administration for third-party programs. We also do, of course, building certification and labeling. Over 134,000 buildings have been labeled up until 2024. And 90% of the Energy Star homes that you will see in Canada, those have been certified by ENERQUALITY, and we proudly do that. We also, of course, are proud to present education and custom training to all of you too, from the list that you can see on the screen, but also custom webinars just like the one that you're on today. Next slide, please, Marc. So when it comes to building and certification, builders have that opportunity to build to a higher standard, and they have a selection of labels to choose from. Really, we have a lot of builders who decide to dual label. So you'll see a lot of homes that are Energy Star and also net zero, have the CHBA net zero ready or net zero energy home. And we also have other labels that you can see listed here. Next slide, please. So a little bit of housekeeping, as I mentioned right off the top there, there will be time for Q&A. Would like to leave those questions until the end. So please do drop in your questions. Marc loves questions and he wants to be able to help facilitate those as best as possible. So please drop those into the Q&A section. And then on our next slide, please, Marc. We will do a little bit, before I get into Marc's bio as well, we're going to get to know a little bit about who we have in the room this morning. So I'm going to launch that poll right now very quickly. And so it's going to give everyone a chance to tell us who's in the room. So you might wear more than one hat. So please let us know. We'll leave this open for about 10 seconds. This is a quick power. This is not a quiz. So if you wear more than one hat, please select more than one. And I will leave this open for another 3, 2, and 1. I'll close that out. So Marc, this is going to give you a chance to see kind of who we have in the room this morning. If there were any titles or roles that we didn't list here in the list, please drop that into the chat. And you can at least see we have the majority here coming from the energy advisor area, builders and contractors, and we have a few others as well too, Marc. Okay. And then I believe our other poll is what brought you here. So I think this is going to help Marc quite a bit to understand too, what drew you to today's webinar? Were you curious about new energy efficient technologies, learning about drain water heat recovery applications beyond code? You're interested in MURB performance solutions, looking for installation guidance or other. So please elaborate in that chat section. Or if it's a question specifically that you have, again, please drop that into the Q&A and Marc will be able to address that. So I'll leave that open for another couple of seconds here. This is fantastic. Everybody's pouring in with their answers. So I'm going to close this out for you, Marc, right now. and the answers. So Mark, hopefully this helps you too. Everybody's a bit more curious, I think. It kind of leans towards curiosity and learning about the applications beyond code. So this is helpful. Okay. So as we do this, I think our next slide is your introduction. Is that correct, Mark? I think
It
yes.
is.
Perfect. So I'm pleased to introduce our presenter, Marc Fontaine, co-founder of EcoInnovation Technologies. Mark is a trained mechanical engineer who has spent the past 15 years focusing on manufacturing and product development in the drain water heat recovery space. He's also contributed to several CSA code development committees and the National Code Council for Energy Efficiency, helping to advance energy efficient and sustainable practices across Canada. With that, I'm going to hand things over to Mark to walk us through how drain water heat recovery works, where it fits best, and how it's being applied in both single-family homes and multi-unit residential buildings. So, Mark, over to you.
Thank you very much. Let's get this started. So, as Joanne mentioned, I'm Marc Fontaine. So that was a handful when she described what we do here. But essentially, on the screen here, I have a drain water heat recovery unit, which is a typical construction that we see on the market today from different manufacturers. And so everything I'm going to talk to you about today, obviously, is based a little bit on the thermal drain product that we manufacture, but is applicable to any brand of drain water heat recovery unit you may come across. So here you see the construction is essentially a central copper drain tube around which is wound a copper coil, which holds the potable water. And then on each end, you can see a no-hub mechanical coupling that's used to do the installation on the drain stack. We're going to go fairly quickly today on most slides. At the end, I'd like to have enough time for questions, and we can go back as required. So drain water heat recovery is essentially a device that's used to recover heat from waste heat, mainly coming from shower activities. And so the shower in the home is what uses the most hot water. Obviously, there's other sources of drain water that may be of interest, like a kitchen sink, for instance. So the way that this device works is that as hot water goes down the drain, it goes through the drain pipe of the drain water heat recovery unit, and then we have cold water coming into the coil portion. And as that cold water goes up in the coil, there's a heat exchange process that occurs where the heat from the hot water going down the drain transfers across the copper cross section and then heats up the cold water. So we end up with preheated water coming out of the DWHR unit. And so now that preheated water we can use to supply a hot water heater, for instance, or the cold side of a shower fixture. And we'll get back to that a little later on. The way that this heat exchanger works is that we're able to get pretty high heat transfer efficiencies by having the unit being installed vertically. So this is a top view looking down at a drain pipe where a drain water heat recovery unit is installed. And you can see that as water goes down the drain pipe, it has a tendency to spread around and fill in the whole inside diameter of the pipe instead of falling in the center as one may expect. And so this phenomena makes for really good contact between the hot water going down the drain and the inner tube or copper tube, and allows for a lot of heat to be transferred across the copper in this fashion. So it's important to note that these devices are meant to be installed vertically. As you install them in another angle or horizontally, they still work, but the performance is reduced significantly. So here we have a typical schematic of how and where drain water heat recovery may be installed in a house. So you have a a shower that combines a toilet and a sink, and so typically the full bathroom suite. And then you have all of this combined into a drain stack, which is typically a 3-inch drain stack going down. And so we would install a drain water heat recovery on the drain stack that services that bathroom below it. Obviously, the layout of the home may be different, where you have the bathroom a little bit further from where you might want to install the drain water heat recovery unit. But essentially, the schematic shows how things work. And as hot water goes down the drain, it preheats the cold water coming into the drain water heat recovery unit. And the preheated water in this instance goes and supplies the cold side of the hot water heater. And so this is how we are able to recover the heat that's captured into the system for reuse. Drain water heat recovery has been commercially available in Canada since roughly the beginning of the 2000s. And there was a lot of interest by utilities and government bodies about drain water heat recovery when it came out. And research was done at that time to basically approve or disprove manufacturers' claims about efficiency. So model homes were put to use, and other other ways to validate drain water heat recovery efficiency. And then based on that, the interest grew, and so the CSA standards came around, which we now see in code, which is basically two standards that talk about how the units are tested for efficiency and constructed. And then from that point on, there were different programs that went that were interested in drain water heat recovery with for energy efficiency programs. And then in 2016-17, Ontario, Manitoba introduced them into their code, energy efficiency code. And then we've been upgrading. I say we different manufacturers have been upgrading drain water heat recovery technology as the years have gone by, and so what we have today is much more efficient and cost performing, I guess, than it was back then. And we're looking in the future going with the new national code and net zero, and with drain water heat recovery playing a role in that. So as you guys probably know, hot water heating is roughly 20% of a home's load, energy load. It can be more on high efficiency homes. And so it's there's not a lot of technologies out there that address specifically the hot water portion. So there's a lot of things you can do for air tightness, windows, insulation, and so forth. But on the hot water side, once you've got a high efficiency heating device, you kind of stuck there. So drain water heat recovery is a good way to come and address that 20% energy load that really not many other technologies can address. So what's interesting about drain water heat recovery is that it's the construction is very robust. So I mean, it's kind of a set and forget it kind of a device. So there's no maintenance to be done. It has a long life cycle. The cost of the ownership is next to nothing. There's no commissioning or during installation or maintenance down the road. So it's a very good device to install in the long term, where there's no degradation of performance, and there's no degradation of performance based on lack of maintenance and whatnot. So drain water heat recovery collects drain water from mainly the shower and other hot water drain sources. And so it now needs to do something with the hot water that it generates, or the preheated water they generate. So usually we send it off to a hot water heating device. So Rainwater heat recovery is compatible with any type of hot water heating device. So this is an example where we have instant gas-fired water heater. And so these devices usually are sized based on the lowest temperature, cold inlet temperature of the year, so that it can supply the correct flow rate of hot water as needed. And so we have an example here where we have a 4 gallon a minute supply capacity for a water heater, instant water heater. Without rainwater heat recovery, and then with rainwater heat recovery, we go up to 5 gallons a minute. So there's like a 25% boost in an allowable flow rate or available flow rate when combined with rainwater heat recovery. If we have an electric storage water heater, which is popular in some portions of the country, and now with electrification coming around, might be more and more seen throughout new construction. We essentially are capable of increasing the capacity of the storage electric water heater by threefold. So having that hot water or preheated water coming into the cold side of the water heater, it obviously increases the inlet temperature significantly, so the electrical element doesn't work as hard, and so you're basically having 3 times as much hot water. So that's of interest also. If you have a heat pump water heater, well, obviously having the cold water coming in a higher temperature, that means that it's not working as hard. So there's some technical challenges in installing these devices in areas where it's not necessarily vented to the outside, where the mechanical room might be on the smaller side. And so having it less requiring to use or take heat from the space, less heat from the space might be of interest also. This is an example here of a 42% efficient unit, and some of the numbers that will provide or will give. So if you have drain water going down the drain at roughly 37 degrees Celsius, and you have cold water coming in at 10 degrees Celsius, which could be an average in different cities in Canada, then you can expect it coming back out at 21 degrees. So you have a close to 12 degrees Celsius temperature increase for the cold water coming in versus coming out. If we have a higher efficiency unit, then we can look from the 10 degrees going up to 27, pardon me, going up to 27 degrees, yes. So that's a 17 degree Celsius increase in temperature. So it's quite significant. Heat recovery rates instantly, as you look at it, are usually in the 8 up to 10 kilowatts of instant power. So imagine you're reintroducing into the hot water heating system 8 to 10 kilowatts of heat load as you're utilizing the thermodrain. Electrification is a subject that's we're talking about a lot these days. And so there was a study done a few years back where it showed that essentially rainwater heat recovery was able to reduce the peak electrical load demand by about 10%. And so obviously some of your high heat loads or energy loads is heating hot water. And so in the morning and in the evening when people are showering, that's when you're also doing your cooking and maybe some cleaning and so forth. So that's where the highest electrical load is. And as I mentioned earlier, the thermodrain unit is reintroducing a lot of energy in the system. So it reduces the hot water heating load significantly. And this is what it does for the grid. We've come across a lot of MLI Select projects in the last few years. with MLI Select, there's the energy efficiency portion. Um, uh, I guess that's how you can gain your points for this program. And so a lot of builders have been doing 40% above code as an option for their small MURBs. And we've talked to many builders in the last few years, and there seems to be quite a lot of interest for rainwater heat recovery. There's a lot of projects that have been done this way. So maybe based on that, this is a typical small MURB. So we have a 6 dwelling unit, so 3 on each side. So this 6-plex study that was done shows basically that, using ENERQUALITY guidelines with the rainwater heat recovery system at 46% efficiency, we're basically reducing about a little over 6% the building's energy load. So this building, I'll get to it in the next slide, but basically has 2 rainwater heat recovery units in it. And so for 2 rainwater heat recovery units, you get that 6%. So usually builders have been finding that it's a good bang for your buck in terms of what investment needs to be put into building versus the energy savings. Rainwater heat recovery units can be installed in a few ways, where you would have it installed on the main drain stack. So this is what we were looking at earlier. So we have a main drain stack on which the unit is installed. The preheated water comes out and it goes and feeds a hot water heating device. Alternatively, we can do something that's similar to this one, where the preheated water goes and feeds the cold side of a fixture. So these two scenarios basically have similar efficiencies. They perform similarly, but maybe the layout of the house makes number 3 here more practical in the plumbing of the drain of the preheated lines versus perhaps number 2. We see a lot of distance as being the installation of choice. Most of the installations are done this way, but number 3 is a good way to do it if the plumbing lines are far away or the bathroom is far away from the water heater. In some cases where we're looking to maximize efficiency, number 1 here is where we would be able to get another roughly 10% boost in efficiency. So the preheated water coming out of the thermal drain would feed both the hot water side of the water heater and the cold side of the shower fixture. So this is kind of dependent on what you're trying to do, but I would say keep in mind that usually number 2 is where we run across the most, and would be a good way to do the installation. In houses where you have multiple showers, there's a few ways to do that. These are examples of what can be done. You have multiple showers, multiple drain stacks, and so you can hook up thermal drain units or drain water heat recovery units in series like this, or send it to the cold side of the shower and then to the hot water heater. So different things, again, depending on the layout, is how you would choose to do it one way or another. What makes more sense for your building. So maybe back to the MURB. So the 6-plex we were looking at earlier basically has an arrangement that looks like number 7 here. So you have on the right side of the building, you have 3 dwellings, and on the left side you have 3 dwellings also. So as I mentioned, if you look at it vertically, you have 1 drain water heat recovery unit installed on a drain stack that services the shower or the bathrooms of the dwellings above. And when I say bathrooms, obviously this drain line can also service the kitchen sink and the dishwasher and other fixtures like that. It's not exclusive to the bathroom, but for simplicity, this is how we sort of show the schematics. And so the drain water heat recovery unit would be at the bottom floor, servicing the upper 2 dwellings. So you'd have 2 out of 3 dwellings providing drain water heat to the thermal drain unit. And the preheated would be would go back to the hot water heaters of the dwellings above. So this is how you would recover the heat. So imagine in a building with 6 dwellings, you have 2 at the bottom of each, 1 unit at the bottom of each stack. So 2 drain water heat recovery units for the whole building. And you have 4 out of 6 dwellings being serviced by this device. In a building that's a little higher, so a 4-story building in this instance, we're usually limited in terms of flow rate through a thermal drain unit because the outlet is a 3/4 inch. And so we usually go with this schematic where we put 2 units on top of one another, combine the outlets, so 2 times 3/4 inch together, becomes a 1-inch equivalent line size, and that goes and supplies the 3 water heaters. Alternatively, this unit right here could have been moved up a story and supplied 2 units, and then this one supplied 1. So there's some variations there, depending again on layout and how the builder wants to do things. But we found that this arrangement where everything's at the same place at the bottom of the dwelling unit is most popular. In instances where we have centralized water heating, so we have a water heater that's in this central portion of, that supplies hot water for the whole building. These are some of our arrangements that can be made depending on the flow rates are required. So if we have a building here with where a 3/4 inch line size can supply the heat load for the hot side of the fixtures, this would be a way to go. If we need a bit more flow rate and we need a 1-inch line, this would be the arrangement for that same building. Maybe we have a building where we have multiple drain stacks, and so this is an arrangement where we can do this. If we would have a higher building, let's say a 6 or 8-story building, then we can think of an arrangement where for every 2 dwellings we would put a drain water heat recovery unit. And so if we had more dwellings above, we would put another drain water heat recovery unit servicing them, and we can go up and up and up that way for larger buildings. So one of the things that's important to know when we're selecting a drain water heat recovery unit is basically if we're looking at a 3-inch or 4-inch drain stack, most manufacturers limit the selection of the drain diameter to that. And then if you need to supply a 3/4 inch or 1-inch line size for your cold water supply, if you have bigger than 1 inch, there's some ways around that. So we can look at projects and give information on how to do that. Make sure that we have the vertical space for the drain stack. So drain water recovery units can go in shorter lengths in the 30-inch unit size to upper lengths of the 70-inch length size. Most of the units are in the 48 roughly length for more performance, and in the 33-inch length for the regular performance, if I can say it that way. And so you're able to fit in a drain water heat recovery on any drain stack, even if you have TYs and other connections on top. You really don't need that long of a straight portion to install it, but that's a consideration for sure. These are examples of installed units. So here we have an example where we have 2 units on top of one another on a drain stack. And then, as I mentioned earlier, the 2 outlets here and here, they combine together from 3/4 inch and make up to a 1-inch line size. And here you have in a house standard drain stack, a unit installed, ready to get the cold lines hooked up. And so these devices, they come with any kind of a connection you want on it, PEX or copper or expansion PEX. So it's an easy install with the no-hub drain couplings. So basically the installer doesn't really need to supply anything for the installation of the drainwater heat recovery unit. He starts with his lines. Um, uh, One thing of note is that the length of the unit, as it becomes longer and longer, the efficiency of the unit also increases. And on the really long units, it's kind of diminishing return, so the efficiency doesn't climb as fast anymore. And so there's a good sweet spot in the low 30-inch units to 40, 50-inch units where you get the most bang for your buck in terms of efficiency versus length. So as I mentioned earlier, all manufacturers have their products tested by a third party. It could be Intertech or UL or others against the CSA B55 1 and 2 standards. The B55 1 is the performance standard. So we send units out. They're tested by the third party against the standard. The performance is measured, and that's given back to us. And then that's the data that we publish in terms of heat recovery potential. So it's the same thing as with heat pumps and windows and other things like that that are third-party certified. At EcoInnovation, we have a little tool which is basically an Excel sheet, which we call our calculator. So it shows basically all the images we saw earlier. And if you noticed, I'll go back up real quick. There were some numbers here on the images. So 9, 10, 11, 7, and 8. So as we go into our calculator, these images are there. And if you have a building that looks like one of the schematics that you see, then you can basically input very little information here and just get an idea of the energy savings that you can get in the year. So here in the configuration, you basically choose the number that you find for your building, and then you basically just put a few things about the showering. So that's your water usage. And then your shower head type, efficiency of your hot water heater, and a few temperatures that are pretty standardized. And then you can put a couple drainwater heat recovery models. Now we show the efficiencies here. So between different manufacturers, as long as that number is what you're looking at for a model, the calculations are the same. So basically, based on how it's installed and whatnot, you end up with a efficiency number here, and then you get the energy savings for the year. So it's a really quick tool to just, either if you're looking for the system efficiency and use your own calculations based on your numbers, or if you're looking at the energy savings and you input the usage here of the hot water. Either way, it's a quick tool to get your energy savings for your building. Drainwater heat recovery unit is under the domestic hot water tab in the Hot 2000 software, and it's also in some of the US on the US side. Some of the softwares are more popular there. A lot of people, as I mentioned earlier, we can get the heat recovery efficiency numbers here, and we can use that in different ways to give energy savings based on hand calculations or other software that may be used. And so this is kind of an overview of what I had to talk about. And if we go to questions, I can go back to slides. If there's something we want to talk about more specifically, it would be the time to do so.
Awesome. Well, thank you so much, Mark. This was really great as an overview, and there are some questions, so that's great. So, first, I'll dive into the Q&A. If you yourself, Mark, want to open up the Q&A too, and we can read through them, and I'll read out the first one to you from Sanford. So this goes back kind of to at the beginning of your presentation. Would it make any sense to add vertical or spiral fins to the inside of the drain tube to help with heat transfer?
Um, we have to understand that this pipe needs to be able to get drain water from any fixture that's in a home. So we're talking obviously about a shower and also a toilet. And so it needs to be a free-flowing type of pipe. So the the drain portion is exactly the same, and any portion of drain, whether it be ABS, PVC, copper, it's the same size, and it's free-flowing. So there's no issues with any sort of fouling, whether it be installed vertically or at any other angle.
Okay.
That being said, we have to keep in mind that we're able to get, roughly 50% efficient units in a 44 inch length. So it's already a pretty high efficiency unit.
Okay, thank you. So hopefully that helps, Sanford. Next question from Cindy. Is there a maximum distance recommended for distance from the hot water tank to the drain water heat recovery?
We find that, as in the examples I gave earlier, you had an increase of, 12, 15 degrees Celsius in the temperature. So roughly, if you have cold water, let's say call it 10 degrees, you end up in 22, 23, 24 degrees Celsius preheat temperature, which is pretty much room temperature. So we find that there's, especially with PEX piping, there's really not any heat loss to the environment. So usually the length is not a big issue in terms of heat loss. Obviously, if you have something like a 60-foot 3/4 inch line, then it takes many seconds for that line to empty itself. So we obviously, if you can keep the drain water heat recovery unit and the hot water tank closer together, the preheated water gets to the tank much quicker, so you don't lose seconds or minutes before you start regaining your energy, right? But it's not, if you're looking at, let's say, a 10-minute shower and you have a 40-second dwell time before that preheated water gets to the hot water heater, it's 45 seconds out of 10 minutes, so it's not necessarily a big proportion of non-recovery
Okay.
time.
Next question was, how would the water hardness affect the efficiency in the long run?
Not so much. Obviously, if you have, what happens with water hardness is you might have some buildup in the pipe. And so the question is, how much buildup do you have? So it's a hard one to answer, because if you're plugging up the cold side of the pipe with a 1/4 inch of sediment, not sediment, but residue, obviously the heat transfer will go down significantly. But if you're talking about surface, then that's not much of an issue.
Okay.
We have to keep in mind that most of the difficulty in the heat transfer process occurs between the pipe and the coil, where that interaction comes together, and that's really the biggest place where it's hard to get the heat across. So the hardness with the deposit of that wouldn't be much of a problem.
Okay. I'm going to read out one more question, then I'm going to do a little wrap up, but we'll keep doing questions right after that. So Jeff had asked, can it be installed horizontally? Is the performance the same? Marc.
So the performance, as I mentioned earlier, goes down significantly when we go from vertical to any other angle. So we found that if you install it horizontally on the plumbing side of things, if you look at drainage, everything's fine. There's no issues or concerns or anything to think about. But in the performance, we usually drop to about 30% of the rated performance. So if we have a 60% unit, then we'll go down to about 20%. So that might seem low, it's a big penalty, but in projects where you have a lot of hot water going down the drain, having a horizontal unit where you can't put a vertical one might still be a good solution in terms of payback. So in a house, maybe not so much, because the hot water load is fairly low. But if you have an application where you have a multi-story building, or you have maybe sports center kind of application where you have a lot of showering and so forth, then obviously we do those, and it's of interest in those projects.
Okay, awesome. And Justin had a similar question. I'm just seeing it here too. He had a similar question about the horizontal application, but he's looking for how this could be installed for a slab on grade application.
So slab on grade is kind of if you have a if you have an area where you can actually put it lower than the slab, that could,
Mhm.
but maybe
A little
accessible, that
higher.
would be a way to go. Usually for those types of building, we're looking at having a two-story building where the bathroom will be on top, and that's an easy install. So slab on grade is not always um, the best way, because you have to have the unit installed horizontally, and
Mhm.
then putting the unit somewhere at the slab level is sometimes difficult. So I would suggest for the slab on grade to sort of, unless there's a really good reason to do it, to sort of move on to projects with 2 stories or more, which is probably a good portion of builds that are slab on grade anyways.
Okay,
It's kind of the limitation of this technology, I would say.
fair enough. Okay. Joss had a question. Is connecting to the cold water side of the mixing valve also common in Canada, or to both the cold water side of the mixing valve and the hot water supply?
Yeah, we don't recommend doing that because the temperature is variable, and the mixing valve flow rate, it changes quite a bit during the year. So you have a problem with how much water is going into the coil of the heat exchanger, going into the cold side of the mixing valve. That flow rate varies quite a bit, and that reduces the performance. So it's not recommended to do that. You would install it, have the preheated water go at the inlet of the water heater or on the cold side of a fixture, not the mixing valve.
Okay. And Sanford's question, can they be buried under the ground where grades permit this?
Um, I don't think so.
Okay,
I'm unsure, but we don't recommend burying.
fair enough. Okay. Joss also had a follow-up question, and then I'm gonna do some wrap up. So Joss's question, do these setups ever cause any legal issues? For instance, I can't remember this acronym, the WWHR unit being on the level of another tenant, for instance.
That would be more like in condo applications where you have
Okay,
yeah. So as far as I know, no.
okay.
You have to keep in mind this device is all plumbing pipe. That was kind of some of the design intent here. So we have a
Mm,
standard drain pipe, which is the same as regular drain pipe, and we have the same for the coil portion. It is copper pipe used for cold water supply. So and again, since there's no maintenance and there's no parts and there's no seals, there's nothing to leak or to change or to service. So as far as we know right now, we haven't come across that. But that
that
being said,
that could that could happen. Uh, and then Edlin had more of a technical question here. How would you know if you need to use the 48 or the 33 inch? Is there a rule of thumb?
okay, so let's say if you're not going to like prescriptive, where they might
Mm,
say a specific number, let's say you want to reach a performance level. So maybe you're looking for energy savings, and for you're doing, I don't know, Energy Star building, and you're looking for another 2 or 3% for your home. So you would size the unit based on that. So listen, I need 2% reduction, and so what unit brings me to that, to get that 2%. Maybe you're building a net zero and you want to maximize your heat recovery. So maybe you put the longest unit you can fit. And so basically, if you're looking at the example with the MLI Select program, sometimes somebody might say, listen, I'm looking to save 4.3%. I'm missing 4.3% reduction in my heat load for my building. So, what drain water heat recovery gets me there? And then we just go exactly to the performance. Maybe we need a 48.3% efficient unit to get us there. So that's how we would choose it. In some codes, it might say you need a minimum 42% unit. So then you just put a minimum 40% unit. So
Okay.
it usually depends on what you're trying to do and how to get to your to achieve your result.
Okay. So there's two other questions, one from JF and one from Ben, and I will get to those, but I do want to do a little wrap up because we're at time. We're going to still address these questions, everyone. But I really want to thank you, Marc, for sharing your insights and your expertise with us today. I want to thank everybody for joining us. I know some people were able to tune in a little late. If you happen to miss this and you're going to be watching this recording, that's totally fine as well. And please send through your questions if you have any. So we do hope that all of you found this session on drain water heat recovery informative, inspiring, and hopefully helpful with for any projects that you have coming up. A quick reminder, the recording, we will have that available to those who had signed up for this session. So we'll send that out to you later today. And also, we just want to thank all of you for submitting questions. This has been really helpful. So thank you so much for that. And we really look forward to seeing you on a future inequality session, whether it be in person or a webinar. So thank you so much for tuning in this morning and taking some time out of your busy schedule. So thank you again, everyone. Thank you, Marc. But Marc, before I let you go, if anybody wants to stay online with us as we address these last two questions, please feel free to. They'll be part of the recording as well. So Marc, two more questions. One, it has to do a little bit with the SB12, so I'm going to have you review this one carefully. So, in Ontario, SB12 Section 3.1.1.126A, exact, requires drain water heat recovery units to be installed vertically within 5 degrees. So you mentioned this might be a bit repetitive. I'm just reading it out now. You mentioned that horizontal installations are possible. Are those actually permitted here or only in other jurisdictions? If they are used in Ontario, is that typically through an engineered equivalency or manufacturer certification? And if so, is that documentation publicly available or accessible for review? And so that was a long question. You
So,
want to look at that.
for the prescriptive, the code
Mhm.
specifically says it needs to be installed vertically and it needs to be B55.1 at a 40% efficient rating. So the short answer is no, it needs to be installed vertically to meet that code requirement. However, if you're building to other standards. I'll give you an example of the Energy Star, or perhaps you're doing the MLI Select. Then you can look at doing something different and then have the engineering calculation done or other ways of doing that. So, but for the SB12 specifically, it needs to be installed vertically.
Okay. And the last question from Ben was, is the drain water heat recovery tech usable for non-basement houses or houses that are hooked up to a septic system that exists, that exits the house fairly high up, the foundation wall?
Yeah, so with septic, it's kind of the same with the slab on grade, depending on
Hmm.
how low the exit is and how much vertical space you have, because you can install units on very short, like 20 inches if you want to. Um, but obviously, if you don't have enough headroom there, then we're looking at a two-story building where we would, service the upstairs bathroom
Okay.
as our main target. Yeah.
Perfect. I think that is all the questions that we received. For those that are still here, I'm going to launch one last little poll for all of you before we hang up. So, have a question, curiosity, have you implemented drain water heat recovery on a project? Three types of answers here, either yes, no, but I'm considering, or no, this is has been your first exposure or introduction to it. We're really curious here to understand too, because when it comes to these sessions, And then Mark, I think there's a QR code just on the last slide, if you don't mind flipping over to that one while we still have a few people here. So as we wrap it up, I want to thank everybody again for tuning in. Your feedback's really important when we have these sessions. We really are curious to know what brought you here. Also, did you find this informative? Is there anything, are there any other webinar topics that you would like us to cover here at EnerQuality? So thank you so much for tuning in. This link to that QR code, it'll be included in the wrap-up email that you'll receive. If you have any questions specifically for Mark, I will also make sure to include his contact details so that you can ask him some questions. But thank you again, everyone. So I'm going to end this poll. And Mark, this has been really great to see too. So yes, the majority, at least 50% of those who are with us have implemented drain water heat recovery, but another good percentage of individuals have been thinking about it. So that's great to see too. Awesome. And I just want to check for one last question. Okay, perfect. Thank you, Ben, for the feedback there. We really appreciate it. So, Mark, thank you again for your time. Thank you for sharing sharing all of this information. And for those of you out there, thank you for tuning in, and we hope you have a great rest of your day. Thanks so much. Thanks, Mark.
Thank you.
Take care. Have a great afternoon, everyone.